Okay, so the recording has started, Kirsten, so over to you.
Okay, super. Thank you so much, Bridget. Sending this message, not disturbed. So
Okay.
hello everyone, and I'm really apologize for the audio issues which we had the other day. I know it's very inconvenient, especially that it was our last lecture, and but it's also given me a little bit of time to have a discussion with Bridget and Kutsai. And so what I assume that you had already studied MQM, which is in your notes, module 24, module 25. Let me just check which module. So it's module 25. So what I've done is I've just amended some of the slides, and as I do with every session, I'm going to very briefly run through the slides again so that we can have a little bit of a review of what happened last week. But yes, please make sure that you study that first section called MQM. It is really critical. I just thought that you'd already covered it, but you're only going to cover it next year. So with that, I'm going to turn off my camera. I'm going to start sharing my screen, and we'll dive straight in. Very strange not to have, I mean, it's always strange because no one is always turning on their videos, but it's even more strange today. So here we go. So going back to Micro 2, which was last week's lecture. Okay, Bridget, if you can just confirm, are you seeing the presenter mode or the...
Yeah, so I'm seeing your Micro 2, but it's in like a double screen, but I don't think it matters.
Okay, hold on a sec.
Yeah.
Okay, so we're all good now.
Perfect.
Okay, so now what I've added in is microbiological management systems. I've put it into the agenda. So we're not going to cover the whole of lecture 2, but I'm just going to focus on the first few slides. So what is really important to know, and you will study this again next year, but it's important to know for these exams, cosmetic products are not expected to be completely aseptic. However, they must be completely free of pathogens, so of highly virulent microbial pathogens, and the total number of microorganisms per gram must be low. If any of you are at the conference, we actually received little red balls for answering that question correctly. So if you are treating anywhere near mucous membrane, so for example, the eyes, or anywhere near damaged skin, or you are making products for children that are under 3 years of age, then there are additional restrictions that we have to make sure that we conform to. So producing microbiological safe cosmetics requires an integrated quality management system, and this consists of good raw material quality, hygienic design of product facilities, which I did mention last time, good production hygiene, and a validated preservative system, which we'll get into in a few minutes when I get into the preservatives. So just for everybody, you do need to know what HACCP is. So it's hazard analysis critical control points, which, to be honest, if you ask me on any given day, I wouldn't know. We just call it HACCP. And then we have current good manufacturing practices. I think I said cosmetic good manufacturing practices last time, but it's cosmetic good manufacturing practices. And this is provided for in the ISO 22716. So if you are controlling a PIF, a product information file, you should know this. Then we also have some products where in ISO 29621, there are certain products, because they're considered low risk, that do not require challenge testing and do not require to have a preservative system. If you think your product is on the borderline, rather just run the PET systems with a small amount, your challenge testing with a small amount of preservative versus no preservative. And if it passes with no preservatives, you can substantiate then your ISO 29621 by showing that the product, even though it was inoculated with microorganisms, nothing grew. And then this is what I was talking about last time. So there's also a guideline how to design production equipment, and this is ISO 14159. and it talks about cleaning, sanitization, etc. Okay, so please remember that. So if we are producing for children under the age of 3 or for the eye areas or anywhere on the mucous membranes, the limit for the total count is 100 colony forming units per gram or per milliliter. And then for all other products, the limit is higher, so it's 1,000 colony forming units per gram. And furthermore, these products must be investigated for 4 of the most common pathogens, and that is Staphylococcus aureus, Pseudomonas aeruginosa, Candida albicans, and Escherichia coli. And you have to prove that they are absent in 1 gram or milligram. Okay, so those are the legal requirements. And now we jump into where I started last week, and that's just to remind you that there's 3 ways that contamination can occur: production equipment, raw materials, water source. Then we went into a bit of history. I don't think it's that important, but I'm sure that it's of interest to all of you. Then how do we use water in cosmetics? I just gave you a little bit of a snapshot about the United Nations, that we are using double the amount of water on a regular basis. And so it's twice the rate of the population increase, and this is going to put severe water pressure restrictions on us in the future. Okay, so we use water for formulations. In the formulation, obviously, in many, many formulations, we use it for conveying raw materials. We use it for cooling, heating, and for cleaning. Then I spoke a bit about non-pathogenic and pathogenic. I'm sure by now you know that. There are also certain organisms that, even though they're not gram-negative bacteria, like the parasite Giardia lamblia, you also find them at such high levels in water that the water becomes turbid. So even though they're not parasites, but even though they're not gram-negative bacteria, we still don't want them in our water. Okay, and there was just a snapshot of what it looks like when you don't use clean water in your filtration systems and in your pipes. Okay, so water sources: tap water, distilled water, deionized water, and reverse osmosis water. What are the ways in which we can purify water? Is chlorination, deionization, coagulation with filtration, distillation, and then pure filtration. But that's how we treat water. Don't forget. Okay, and when we're testing water, we use one organism as an indicator organism. This is Escherichia coli. It doesn't mean that that's the only gram-negative bacteria that we're worried about, but because we know that that is one of the toughest gram-negative bacteria to kill, that it's present everywhere, that it's a very good indicator of sewage or of intestinal flora, and that usually they are they're ubiquitous, which means that they're around in large numbers. That's why we just check for the Escherichia coli. So it's an indicator organism. Capital letter Escherichia, small letter coli, usually in italics, underline if you can. Right, so how do we test for water? So it's interesting, there aren't really any guidelines for testing water, but a good guideline is to test your water every day. If you have like a food facility and you're able to, it would be great if you could test your water on a much more regular basis. Okay, so then we just spoke about the ways in which we can control microorganisms. So this slide is the most important. Please take a snapshot of it. So it's the way in which we can purify water versus the way in which we can control microorganisms. So, I mean, we could heat water, that would also help, but it's not really an accepted method for treating water. And at the same time, it would be very expensive to use ultrasonic or high pressure to treat water. So we've got the methods of treating water, and then we have the methods for killing microorganisms or for controlling microorganisms. Okay, and that was the end of last week's presentation. So please don't forget those differences. And now what I'm going to do is I'm going to go into the very last lecture of year one. Congratulations, everybody. Keep your minds on the big stuff. Just remember, there are key words. I know I heard you asking the questions last week when I was at the airport, and you were saying, but how do we answer the questions? And we actually do have model answers, but I can't really say that they're model answers. What we have is, it's an answer format, and we look for certain key words. And so each key word might receive 1 green tick or 2 green ticks. And this means that is worth 1 mark or 2 marks. So we're looking for words like gram-negative will stain red, gram-positive will stain blue, and we give ticks for red, and we give ticks for blue, and if you've connected it correctly to the right colors. Why? So we look for maybe a thick outer lipo layer. So these are keywords that we look for. Please do not think that the more you write, the more marks you're going to get. That is absolutely not 100% true. Yes, there are times it'll say discuss or motivate, or there are sometimes you do need to write more of an essay. But in general, please just try and keep it to bullet points, or just try and make it very, very easy for the people that are marking your papers to just see that you understand the key concepts, that you understand the keywords, and you can link them. Okay, so preservatives, unit 26. Okay, so in this module, we're going to basically discuss how we choose what is the ideal preservative, how do we choose the correct preservative, and then how do we know that we have an effective preservative system in our products, and which other products that we can use that can contribute towards our preservative system. Okay, so eyeshadow dating back to the 1300s suggests that Egyptians were already using copper sulfate to preserve their cosmetics. And today we continue to search for ways in which we can protect our products. So preservative is preservation is a process which either inhibits or kills microorganisms, thereby protecting the product from microbial attack. So we do need to protect the product because it can damage our brand, but we also need to make sure that we do not cause contamination and any kind of infections for the people using our cosmetics, not only while they're using the cosmetics, but not only while they open their product, but for the foreseeable use of that product's life. Okay, so we have a huge, huge challenge. Preservatives are not very popular at the moment. And I mean, they haven't been for quite a few years. We've had a lot of very, very good preservatives that were available to us as microbiologists or as cosmetic chemists that are now that are so limited and so restricted or completely banned that we don't even have access to those preservatives anymore. And that means that every single year, the list of preservatives that we can use is smaller and smaller. Just remember, all materials are toxic at certain levels. It's just the dose that matters. So please, the challenge is to use the minimum amount of preservative in the best combination of ingredients to provide protection for your products. I just added this little snapshot at the bottom. I should have really taken the reference. I don't even know. But it's an idealized belief amongst consumers that preservatives are a fundamentally bad thing to have in a cosmetic, coupled with a hazy, false nostalgia, which promotes the belief that products were somehow more wholesome and better back then, maybe bringing us dangerously forward to the past instead of safely back to the future. So it is very important that as cosmetic chemists that we also challenge these precepts. We need to push back on our marketing people who come to us and tell us, I want a completely preservative-free product. And unfortunately, microbiology is kind of like a thankless job. It's like being a mother. No one sees what you've done until it's obvious that you haven't done what you were supposed to do. And that's when your product becomes contaminated. So it's very thankless. But we have to be ambassadors for preservatives, and we need to make sure that when preservatives are limited, that it's done for the correct reasons and not just because marketing wants to make claims. If we free from everything, eventually we're going to free from absolutely everything until we're down to water, and we'll be selling not micelle water, we'll be selling micelle free water, and really we'll have nothing left to use in our portfolio to manufacture safe, good cosmetics. Right, so microbiological terms, just so that you understand. So disinfectant is not something that we would normally use in a cosmetic. It's something that destroys all microorganisms, but it's usually, we use it on inanimate objects. Aseptic means that it's completely free from microbial contamination, not always completely necessary for cosmetics. A germicide is something that's used to kill microorganisms. Cidal means to kill. Stasis means to stay the same. So we're preventing growth from happening. Biocidal is obviously to kill life. Okay, what did we discuss in our first two lectures? And we said, what are the organisms that are most likely to cause contamination in our product? And those are bacteria, yeasts, and molds. You can see the different variety of temperatures. Molds prefer a little bit more of an acidic medium, where bacteria prefer a little bit more of a neutral pH. Bacteria also, you can always just think that we always get infected by bacteria, and so that's between 30 and 37. When we get a fever, our body goes up past 37 so that it can try and kill off those organisms. Gram-negative bacteria are difficult to kill because of the complexity of the multi-layered cell wall. Remember that it has an extra liposaccharide layer around it. Oh, just need a sip of water. Thank you. And then yeast, they can survive in a wide temperature range, but often they're just happy at room temperature, which is normally where our cosmetics are kept. We're more concerned when it comes to use just with the aesthetics of the formulation and the smell of the formulation, and very often they'll lose viscosity. And a good example of that is Candida albicans. Then molds, it's usually aspergillus that is responsible for contamination on your products. Right, so preservative strategy. So preservatives there, as I said before, to protect the product from low levels of microorganisms, but they're there to protect the consumer and the product during the foreseeable use of the product's life. So nowadays, I think you have to include the PAO, and your product will see, you will know whether your product has 6 months that it needs to be stable, whether it has 2 years that it needs to be safe, or 30 months that it needs to be safe. Preservatives are not there to cover up poor manufacturing practices. Okay, so we actually discussed this in lecture 1, but just to repeat, what do microorganisms need? They need water, they need air, they need nutrients, and they need growth factors. And as we know, cosmetics are excellent sources of both nutrients and growth factors, and invariably also a really solid amount of water for them to grow. So that means that we really have a challenge to try and preserve our products. And just to remember that the glycerols, celluloses, fatty alcohols, esters, sterols, proteins, and vitamins, these are all excellent sources of food or nutrients for microorganisms. So cosmetics are like the perfect environment for yeast, molds, and bacteria to grow. So to minimize the bioburden, we need to consider the following factors. We need to consider formulation factors. So is it an emulsion? What is the pH of your formulation? If it's pH 2 or if it's pH 12, do we need a preservative system? What is the nutrient availability? What is the water content? And it's not just the water content, but it's available water to the microorganisms. Do we have things like natural extracts, which might contain a certain amount of bio load already, bioburden? And then we need to consider the processing plant. So I've already mentioned that ISO procedure, where it tells you not to have little elbows and water that just sits in your system. So you need to think about how your processing plant is designed. And then you need to think about things like this. What are the time lags? Are you manufacturing a product and then leaving it in the vessel before you fill it the next day? Do you have certain hotspots in your factory? Do you have any in-house resistant organisms? And there are actually many, many factories around the world, and really with big multinationals, that do have these in-house resistant organisms. So what is really important when you have an in-house resistant organism is to change the way in which you disinfect your vessels and your piping from time to time. So use one procedure for 6 months and then another procedure, or you use the same procedure all year, but then break up every couple of months by using a different cleaning procedure. So you'll either use caustic and then shift to something more dramatic, or the other way around. So just change up your cleaning systems quite regularly, and then your filling procedure. So are you filling in tubs and then waiting for your product to cool down while everyone goes to lunch, or maybe even worse, they go off for the weekend, and those tubs are lying there cooling down, and then only putting the lids on when everything has moved back to room temperature? Okay, and then the other thing that's really, really important is packaging design. So I think someone asked me a question about this the other day. I'm going to show you on the next slide. You're going to see or in 2 slides time, you will see some packaging designs, which also can reduce the amount of preservative system that you need. You need to also consider, do you have a tub and do you have a lot of head space? Remember, we discussed head space. So if your preservative is only in the if it stays out of the oil phase, and the water phase, and it's not completely dissolved, then it will create a little bit of evaporation on the top of the lid, and then drop onto the top of your product and cause bacterial contamination. If your packaging is completely air-free, maybe you don't need a preservative, and the way to find this out is to do a challenge test. And then does your packaging absorb certain preservatives? That can also be an issue. So, and then of course you need to always consider your GMP procedures and certifications, your export conditions, in-house testing. So there's a lot of things to think about and a lot of things that you need to look out for. Okay, so under formulation factors, so that is kind of the heading. So just remember, if you get this question, what do you need to take into consideration? It will probably be worded something like, you are the microbiologist of a You've been asked to select a preservation package. How do you go about this? Just think logically. What the first thing that you say is, well, the 3 most important things is the formulation factors, the processing plant, and the packaging design. And of course, you need to always follow GMP procedures and certifications. And once you've written down those kind of 4 headings for yourself, the rest will just come into play automatically. You will remember everything. But just dilute the questions and think, how was this represented to me? Okay, so formulation factors. Obviously concentration of the preservative, then water content. So if you're making talcum powder or oils or stick deodorants and lipsticks, you may not require preservative at all. What is the contact time that you allow the preservative to interact with the cosmetic before you fill the cosmetics? What is the microorganism load? So how many microorganisms are coming into your product through the raw materials or through the water? Then the pH of your product, very high and very low products like hair relaxers don't need. Organic acids, for example, they are only effective if you use them in an acidic medium. The minute that you put them into a neutral or high pH system, they're going to create salts, and then they're no longer effective preservatives. So this is really important to remember. A lot of people are running to organic acids because it's a nice soft preservative, but just remember, if it's not in the right formulation, it's not going to work. Then, of course, the temperature that your formulation goes to. So if you're creating an emulsion and you say have waxes in there, and you're taking both phases up to 80 degrees Celsius, and then bringing the temperature down and adding your preservative at 40, which is what you should do, then you probably have killed all of the bioburden that was already pre-existing. Maybe not everything, but at least 99%. Okay, so then that is a consideration. Or are you cold processing? And then you know that you need to really, really make sure that your bioburden that existed in the raw materials and in the water can be controlled. Okay, then you need to think about the interactions between the raw materials in your products. So anionic surfactants can inactivate cationic preservatives, so it kind of makes sense. They'll neutralize and turn into kind of non-ionics, and then your cationic preservative won't work. The same way that proteins can inactivate quats as well, and they can also inactivate parabens and phenolics. So think carefully about what are your raw materials, especially if you're using biologicals, and if you're using a lot of natural oils and a lot of natural products. Please check these raw materials and make sure that you understand the bioburden that you're introducing into your product. Okay, and then the enhancement or the inactivation of preservatives. Okay, processing factors. So now we're on the third consideration, what you consider as a microbiologist when you're thinking about what preservative package to use. So the second one is processing factors. So here you need to consider, do you ever rework the product? If you're going to rework the product, are you going to be heating it up? Are you going to be deactivating the preservative that was added in the first round? So then you need to maybe reconsider to adding more preservative to your product. You don't know how that's going to affect your product, but these are things you need to think about. And then the amount and the time of heating, so especially when you're making emulsions. The storage time between manufacture and filling, as I mentioned. Then adequate solubilization of your preservatives. So you need to make sure that your preservatives are actually soluble in the correct phase. We'll get to that just now. Then the time of processing before preservative addition. So how long does it take you to manufacture that batch? How long could the yeasts be multiplying and doubling every hour while they're just sitting there waiting for you to add the preservative? Okay, and then processes should be standardized and they should be repeatable. Right, now into packaging considerations. So there on the right-hand side, it's a very nice picture of an airless pump. So you can fill it up with serum. If your serum is 100% silicone, or then probably you don't really need a preservative in any case to preserve your product. But let's say that it's an emulsion. So it's all about how much air is available to the microorganisms to grow. So very often with airless packaging, you actually do not need to preserve your product, but you need to check. So you can have sterile products in multi-dose containers. So these must be capable of self-sterilizing if contamination occurs. Then you have non-sterile products must be capable of reducing the bioburden to an acceptable level for the duration of the use of the product. So you cannot think that, okay, you're packaging it in this really nice little tight container, like in a little seal, one of those like strip things, maybe you've even got nitrogen in there. It's not good enough for you to consider that. You need to consider that once your consumer opens the package, how long will it be that they are going to use that product with the package opened? Then large opening packaging, such as jars, they have a much higher risk of contamination than narrow openings. People might have jars of hair conditioner, they put it into the shower, they don't put the lid back, and then you sit with this really, really nice humid conditions, warm, humid conditions in your shower cubicle, and this can be the perfect opportunity for microorganisms to proliferate. Then your interaction with packaging, as I mentioned, so LDPE can absorb parabens. That is one very important thing. So by the way, we can still use parabens, just short-chained. I'll show you just now. Once again, preservatives are not a substitute for poor GMP. Right, so what is the ideal microbial agent? Just need a sip of water. So on the right-hand side, it's a kind of like a very common German saying, an eierlegende Vollmilchsau. So it's an egg-laying, full cream pig. And that is really what we're expecting, this almost impossible thing that we really want as our ideal microbial agent. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characteristics of what should be an ideal microbial agent. It should be broad spectrum, so it should kill all bacteria, but also yeasts and molds. It should be effective at low concentrations. This is not always the case anymore, because as we move to softer and softer preservatives, we using higher and higher concentrations of softer, less effective preservatives. They must be water soluble and oil insoluble. So they need to stay in the water phase. Do you remember how we spoke about headspace protection? So you need to make sure that your preservative is completely dissolved in the water phase. And if it's completely dissolved in the water phase, then you should have headspace protection. Your ideal preservative microbial agent should be completely compatible with all raw materials. That is very often not the case, especially when it comes to fragrances and color. An ideal microbial agent should have no color, low odor, be very stable over a long period of time. So if you buy, very often we're using small levels of different preservatives, and it might take us a year to use up to 25 kg of preservative. So just remember, you need to buy something that has got a good shelf life in itself. Okay, it needs to be safe. So it needs to be safe for everyone that's using it, but also safe for everyone that is working with it. It needs to have a measurable activity. It needs to be convenient, so preferably a liquid, not a powder. Powders have become very unpopular in manufacturing environments. And of course, we want it to be cost effective, and we want it to have worldwide approval so that we can export all around the world. Okay, so how do we test our cosmetic products? So what we can first do is we can do a total colony count. Okay, so this is where you basically take your product, you do some dilutions, you put it onto a petri dish, and you can count the colony forming units on a petri dish. But this doesn't really give you an idea. It just tells you, okay, yes, there's some microorganisms in my product, or there's no microorganisms in my product. And if you haven't used the right agar, so if you haven't got the right media that you've selected, then also the microorganisms, just because they're on the wrong media, might not grow, but they will still be in your product. And now they are growing in your cosmetic product. So what do? So we take our preservatives and we first do an MIC. So this is a minimum inhibitory concentration. So it's the lowest concentration of the preservative system that will inhibit microbial growth. But this is extremely lengthy. So now we're testing every single component of the preservative on every single different microorganism. So every microorganism will have a minimum inhibitory concentration, and you can usually get this from your preservative supplier. Then we can do an aerobic plate count. So as I was saying to you, so it's very, very similar to doing a colony forming unit count. So this is when you just look at how many organisms are viable. But what is essential is to test your preservative system in the final formulation. And that it tends to mean also in the final packaging. So make sure that even if you've launched, that you resend your product in the packaging that it's sold in and go and do a final test, challenge test. So we call it a challenge test or an adequacy of preservative challenge test. That's the full name. And some people also call it a preservative effectiveness test or a PET. But please remember it as a challenge test or adequacy of preservative challenge test. I wish I could ask if you have any questions, but there's no one there. Right, so how do we do you don't need to understand this through and through, but just to get the general concept, how do we do a challenge test? So the purpose is to test how robust our preservative system is. And the way to do that is to actually inoculate our cosmetic product with organisms. So we take a mixture of organisms, and at the moment these are, or usually are, Staphylococcus aureus, Escherichia coli. Why do we use Escherichia coli? Because it's an indicator organism, because it's the hardiest of all microorganisms, ubiquitous, it exists everywhere. And we know that if we've killed off the Escherichia coli, we've probably killed off all the other gram-negative bacteria. Then we also test for Pseudomonas aeruginosa. We test for one yeast, and that is Aspergillus Candida albicans, and we test for Aspergillus brasiliensis, or you might have known it as Aspergillus niger. So microorganism survival is monitored for 28 days, and you need at least 100 or 150 milliliters or grams of the product to run the test. So what we do is you take 10 to the 6 of coliforming units per milliliter. And usually you can just buy these little kits if you're going to try and do the efficacy test yourself. And it comes with the 5 organisms in this kind of like broth. And then you can inoculate your samples. And what you do is you inoculate them. So you actually intentionally squeeze in these 5 different microorganisms. And then you squeeze them in on day 7, on day 14, on day 21, and on day 28. Then you do a series of dilutions, and you plate in an agar plate to count the survivors. I don't know if you were there for, we attended a very nice lecture yesterday where they spoke about all of the new systems that have come into play, where you don't even need to do these serial dilutions anymore, where the more modern equipment can actually determine the log reduction without going through all these steps, but it still does take time. Okay, so there are all these criteria. I would not, unless you actually are a microbiologist, stress too much about understanding each and every single criteria. So basically, there are 2 different criteria, and this is DIN ISO 11930. And if you send your cosmetic products with your chosen preservative system to microbiology companies, testing labs, they will test this. So at the end of the day, your Aspergillus brasiliensis must show no increase. The Candida albicans must be reduced by no less than 1 log at day 7 and show no increase from day 7. So it's given kind of a lag phase. And then for bacteria, the product must demonstrate no less than 3 log reduction from the initial count on day 7 and no increase from the day 7 count to 14 days and 28 days. Okay, so South African Department of Health has published sort of a draft regulation relating to labeling, advertising, composition of cosmetics, and Disinfectants Act of 1972. But in all essence, what we are currently doing in South Africa, until someone can prove me different, is that we are using the EU criteria for determining challenge test efficacy. Okay. So other factors which affect preservative efficacy is pH, processing, raw materials, interaction, packaging. Why is it good to do an MST? So an MST or challenge test, and this is to develop preservative system, which one, how much, determine your product susceptibility, which microorganisms grow in what, determine the quality of your raw materials, so you need to test to make sure, and then to validate your manufacturing processes, and this is necessary for your PIF. Okay. So luckily for us now, there is this ISO 29621, and this tells you that you do not require challenge testing for all products. So if these products are very low risk and you can prove that they are very low risk, you need to have that justification in your PIF. But these are the guidelines. Okay, so let me just read the thing too. So some products present a very low risk of microbial and microbial due to their characteristics. These include the product formulation, the product conditions, packaging, or combination of these factors, which creates a hostile environment for microbial survival and growth. And some of the examples of that is anhydrous products, so products that don't have any water or have a lower water activity, products with a pH above 10 or below 3. And if your product is borderline, please just test it with and without preservatives, just in case. Products with a high alcohol content. So if, for example, perfumes, if it has more than 20% of alcohol, you don't need to have a preservative. Products which are filled at temperatures above 65 degrees Celsius. So this means filled. This doesn't mean created the emulsion. This means that you've actually filled them at high temperature. So this can be lip balms, but I think lip balms is probably not the best example. Maybe lipsticks are probably a better example. So products which contain raw materials that can create a hostile environment, such as strong oxidizing agents, propellant gases, or polar organic solvents. So, for example, when you're making hair dyes do not need a preservative. Then, if your product is packed in packaging that does not allow contamination during use, example, pump dispensers, pressurized containers, or single-use products. But be very careful with these sachets. Very often that will indicate that it's a single-use product, but make sure that your sachets are not too big, because then people will keep them and will use them over and over again. So then maybe just to be secure, you need to put in a very low level of preservative. Test them. Okay, products which are produced according to GMP and have characteristics that do not support microbial growth do not require challenge testing. However, every exemption from challenge testing has to be properly substantiated. So make sure that in your PIF, you don't just ignore the whole micro section or the challenge testing section. You go in and you say challenge testing. Product was not challenge tested due to the following hostile reasons. The product is produced below this, it's it's in this packaging, it's whatever. Don't leave it out completely. Make sure that in your PIF that you've got all the substantiation of why you have not done challenge testing. So this question will also be disguised as something like, you are a microbiologist or a cosmetic formulator. Your marketing manager has asked you to manufacture a product that does not contain preservatives. Is this possible? And if so, how would you do this? So this would be a prime example. List these things. You can say you could make a product with high alcohol. You could make a product with a high pH. You could make a product, and you can list all of these things where you do not require challenge testing. Okay, so just read the question properly, read the question carefully, and try and interpret what are they asking you. Okay, so then these are just some potentially harmful microorganisms. You can go this, but it's not 100% necessary. But these organisms actually can cause quite serious reactions. And trust me, when somebody loses their eye, they will come and they will follow up and challenge you on that. Right. So what can we add to preservatives to help them preserve our product? So we call these like co-preservative additives, or we call them I'm just trying to remember whatever, I can't remember the name. So acids and alkalis. So if you're producing a product that's got salicylic acid in it, it's probably dropped the temperature down to a reasonable level. And then what you can do is use things like sorbic acids to accentuate that, or to help preserve your product if it's not below a pH of 3. Alcohols, any alcohols will help preserve your product. Not entirely. Benzyl alcohol, you can have growth in a product that has low levels of benzyl alcohol. So make sure that you're not just using that as your sole preservative. Cationic surfactants. Cationic surfactants are very good at helping to preserve if they're in a cationic system. But if you have an anionic surfactant and you're using a cationic product in your system, these will offset each other and you'll just end up with salts and with a whole lot of precipitation at the bottom. Anionic surfactants can also help if it's in an anionic system. Then esters like ethyl hexyl glycerine is a very, very nice product. Then humectant glycols, glycerine, caprolol glycols, desaline glycols. These products are very often used in preservatives that are sold that are combination products, and they do help and they are very nice. Caprolol glycol can also give you some kind of emollient properties. Then phenolic antioxidants, these will definitely help, but they've also been very much limited in how much you can use them. Botanical extracts, so like certain botanical extracts will have preservative activity. Chelating agents. So chelating agents are really, really important in your formulation, but it's not that they actually act as preservative agents. What they do is they help the preservatives to penetrate into the cells of the microorganisms by removing the calcium ions or the magnesium ions from the surface and making the microorganisms more vulnerable. Then there's certain colors that can also help with preservation. Then fragrances and flavors. So, for example, phenethyl alcohol. I think phenethyl alcohol smells like roses or something, but that can also help to preserve your product. And then, of course, we have essential oils like lemongrass, oregano, and tea tree. But trust me, tea tree is not as effective as you think. Please do not launch a tea tree product and then fail to do a preservative. You need the preservative system together with the tea tree. Okay, so on this journey of ours to try and find safer preservatives, everybody has trying to find really the way in which we can really minimize the use of preservatives, but still make sure that our product is properly preserved. So how do we use more natural, sustainable, and greener, gentler alternatives? Add this to the cost implications, and from natural formulations, working with restricted list of antimicrobials that natural and organic standards will permit, you get a very limited selection of preservatives that are left to you. So how do we deal with this? So the way that we deal with this is something called hurdle technology. And basically, hurdle technology is where we take all of these combination of ideas and factors into consideration, and we combine them together. So let me read the definition of hurdle technology to you. Hurdle technology is a term used to describe the intelligent combination of different preservation factors or hurdles to deteriorate the growth of microorganisms. So this can be a combination of various things. And this is obviously adherence to current good manufacturing practices, appropriate packaging, a careful choice of the form of the emulsion. So just by changing your emulsion, you can also limit the amount of preservative that's required. You can try and produce products with a low water activity. You can use high or low pH values to significantly reduce the amount of preservative required. So if your product is at a pH 5, it's not low enough to not require preservatives, but it can support that you use very low percentages of preservatives. Then you have a modified atmosphere, so you can include nitrogen into your sachets or whatever. And then, of course, the use of multifunctional ingredients. So this is called hurdle technology, the intelligent combination of different preservative factors. Okay, let's skip that slide. This is the next two slides I've taken out of my official presentation when I presented this presentation to the IFSCC, because I feel I'm not putting this up to make companies look bad. I'm just putting up and naming and shaming these companies because I want you to understand how easily this could happen to you as a microbiologist. So these are really big names, and sometimes these brands have been completely destroyed by their recalls because of microbiological contamination. So please, this is just for your interest, but please realize it can happen to you. Some more recalls in the more recent past. You can remember L'Oreal had the Mizani 25 Miracle Cream leave-in conditioner. And this caused such a kind of, today in our world of social media and Instagram, these things can really be blown out of proportion. So it's very important that you make sure that your products are protected. So this is Clean and Clear Morning Burst Facial Cleanse on the right-hand side. It was Johnson & Johnson. Yeah, it can happen to anyone. And then a little bit more seriously, but if you Google Buchi Laboratories Medlight Remedy, probably the first thing that you'll come up with is that it's actually killed a whole bunch of vulnerable older people in a nursing home. And this thing went absolutely viral. I mean, it nearly destroyed this very, very exceptional brand. And it's really important for people to understand that bacterial contamination can really kill people. So please be careful. Please consider your responsibilities as a microbiologist. Please consider your responsibilities as a cosmetic manufacturer. The right preservative system is not to be missed. And then this is the EU's Annex 5. So I've just taken a snapshot. This is a very old snapshot. It's done in 2021. You need to go. You cannot, that's why I've kind of cut it off, because I don't want people to think, oh, here's an Annex 5. No. When you're developing a new cosmetic product, you have to go into the very, very latest update of the Annex 5. And you need to go and have a look at the products that you are choosing to use and go and check their recommendations. So there you can see the salicylic acid. It says it cannot be used at higher than 0.5% as a pure acid. It's not to be used for, and I don't know what it says, but then it says there, salicylic acid, not to be used for children under the age of 3. When you get to the parabens, it will tell you that the combined amount of short chain parabens that you can use is 0.14%. So it doesn't tell you just for methyl paraben or just for propyl paraben. It tells you the combination of all parabens and what the total usage level can be. But this Annex 5 changes year on year, and it's really important that you go to the very, very latest Annex 5 to double check. And I would suggest as well, when you do your projects next year, make sure that the preservative system that you choose for your shampoo or your lipstick or whatever it is, that you go in and you take snapshots, that you show that you've considered the Annex 5 in your choice of preservative. Okay, so I just made a free from can because it's just like my little bugbear, because, free from preservatives, free from petroleum, free from silicones, free from this, free from that. And eventually we're just going to have water that's free from micelles, and that's all that's going to be left to us. So please be an ambassador. Please protect all products unless there is really a justifiable claim. And make sure that if you're going to use free claims, that you are correct in claiming preservative free, because it's no longer allowed to say, oh, my product is preservative free if you're still using products that can be that are listed in the Annex 5, such as capryl glycol or phenol propanol and things like that. So please don't be an ambassador for free for. This is just some comments about the latest updates, but these are things that you can go and have a look at yourself. Please make sure if you're using these products, especially SITMIT. So SITMIT, the regulations right now are changing a lot, and methyl thiazolone is, because we are using more and more of SITMITs, we actually are developing more and more allergies towards these products, and they keep limiting the amount that you can use. So I think right now it's reduced down to 15 ppm in rinse-off products. So please double check all of your products. Make sure before you launch that whatever your preservative supplier has recommended to you is actually still covered. by the latest Annex 5. So where are we going? Well, hopefully we're going to get some preservatives added in some way to our Annex 5. Oh, this should say 2025. Sorry, let me change the slide. But there's a lot of really, really good work done by a lot of people, especially with regards to peptides. So these are called AMPs, antimicrobial peptides. There's a lot of work that's been done with using microorganisms to control microorganisms. So in other words, you actually put in, say, some harmless microorganisms into your formulation. Number one, it can give you it can have some benefits in that you're restoring your normal microbioflora on your face or on your skin. But at the same time, it helps to prevent other bad microorganisms from growing. So lots of good work that's happening out there. Please keep up to date with all the technologies. And I just wish you the very, very best of luck for your exams that are coming up. Just remember, I know it's a lot of work to cover, but just read the questions carefully, think about what they're asking you, and make sure you understand the difference in the questions. There's nothing more frustrating than seeing that you've got someone who's really going for a top score, and then you see that they've completely misunderstood the question and they get 2 or 0 out of 20, just simply because they've misread the question. So read the questions carefully, try and understand what the lecturers are trying to understand about what you've learned, and you'll be great. So all the best. Cheers, everybody. That's the end of, and let me phone Bridget to tell her that she can stop recording.